We have audio now? Yes, we do. Please confirm that the audio is working now. The deal is that I cannot hear myself, so it's very difficult to know. Okay, is it too loud? Is it too not loud enough? I think I'm pretty much on the soft spot. You good? Okay, finally. I mean, this thing is like a pain in the butt. Okay, hi everybody. So we have a couple of viewers right now. Hopefully there will be more. Okay, so just to wrap up my life a little bit. So I quit the job I was working at. So I'm full-time doing a lot of things right now. And surprisingly enough, I haven't had much time to actually get my setup to be a bit better because I'm still doing some subcontracting work for somebody else that I was doing previously. That is drawing to an end as well. So hi Daniel, hi everybody. Dane, Turbo 128, Daniel, my wonderful engineer, awesome partner. Okay, so what happened is that, so I've been busy. I would like to stream a couple of times, 2-3 times a week from now on. The setup will get better and better. Hopefully we can get more people over time. We'll try to make it seamless. The time that the chat or the streaming will be is unknown. I guess I think we're going to go from one place and we're going to go to another. Nothing is predestined. Nothing is really set up or planned. I'm not much of a planner anyway. So the deal is really to go from what we had, the situation we were before, and get to the next level. I know right now that I've been trying to fix a problem with the VDMA that is still on the board right now. So right now I'm going to avoid using the VDMA. Sorry, I'm going to avoid using the VDMA because in a certain circumstance, when I'm transferring data from the main memory, the SRAM, to the video RAM through the SDMA to the VDMA, when there's a certain situation, it doesn't complete the data. It doesn't complete the transfer. It's like all the data has been transferred, but it's not all read back to be written in the SRAM. So it just stays there till a new bunch of data comes in and then finish that thing, but it's located at a different place. It's a big mess. So I think I found the problem. I still need to work it out, but I'm working off an old load today. So for the time being, any transfer to the memory to the VRAM will be done through normal code, and then later we'll integrate the VDMA. So the only thing I've done since last time I did that is that what I did is then when I created the sprites, first of all, they were too big. I created them separately. I copied them. I have to admit that these sprites existed before. I just copied the look of them and the color palette and everything. But I transferred them into Asperite. I don't know if it's even known. So if we see the size it is now, I could probably see how they were before. Let's try. No, not this one. No, that's a failed attempt to do something. Okay. Sprite. So many things here. This is the smallest. Yeah. Anyway, the idea here is that the sprite was twice as big. So if I, just to give you an example, I would go and actually, you know what? I should be doing it this way. So it was basically like twice as big like this. So anyway, when I rendered them out, I rendered them into individual files. And the plan was to load every single files. And I thought, oh, this is a bit too much work for my own taste. So the only thing I've done since last time we did the last stream was to reduce down the size of the character in the sprite, which is really the size it should have been in the first place, because when you work in 320 by 240, what happened is that the pixel is doubled. The size is doubled, which means that 32 pixel sprite by 32 will be pretty big, which is, you know, well, considering that the sprites in the Commodore 64 were 21 by 24, something like this, I mean, it's going to be definitely bigger, but nonetheless, the character ends up being pretty small. So if I run through every, I think I showed that before. So we have the different, you know, position of Jumpman going about, getting hurt, appearing, the whole shebang. So what I did is I used a sprite, and what I did is I did a, if I remember well, I did an export. No, actually no. I did not do an export. I did a export sprite sheet. And what I did is that I literally create one single line of all the graphics together. So today what we're going to do is we're going to load that file. And within that file, we'll be assigning every, we're going to dump that file into memory in the video RAM, all of it. And then we're going to assign, we're going to create a addressed, like a base address of every beginning of every sprite. And then this is the address we're going to point to the sprite address pointer when we want to make it appear. So today what I would like to do is literally load that thing in memory and create a little bit of code to create some tables of base addresses of all these sprites, to have like, to create multiple blocks of sequences of Jumpman doing certain things, like for example, the walk cycle right, the walk cycle left, the jumping. I mean, we're kind of far to get everything working, but tonight we're going to try to get, I would be happy if I was able to get it to walk. So the first thing we'll do is load it up, find the sequence that we need to go left and right, possibly. Try to write the code to actually get it to have the right sequence. We'll probably add the joystick. We'll try. If after 3 hours we didn't get it to move, we'll stop, but we'll do it next time. But I would like to do, just position the Jumpman somewhere. No collision, of course. I guess the collision will be next after that. I need to get it done, get it finished. Although there's already some code in Viki to do some collision, so we could try that. That'd be awesome. That's probably one of the reasons I'm doing that, actually. So we'll start at the beginning, which is get the sprite on, write some code to get the right sequence of writing walk cycle, left cycle, right walk, left walk, to create some tables. And then when we use the joysticks, we're going to try to figure out how to go, okay, what is the position I'm in, and then go into the other cycle and move on and turn around and that kind of stuff. So this is the target tonight. I hope you will find it interesting. Again, I'd like to make some disclaimer for people watching, the people will be watching later. I don't consider myself any, you know, I don't think I'm that great at coding. I'm sure some people might come around and say, well, you could have done this thing this way, this way, this way. Listen, I'm really making it really as easy as possible. I'm sure people will appreciate that for people that want to start and try it. I'm very literal. I don't like to carry too much, you know, addresses and direction and stuff like this. It's becoming too complex and it's a bit of a nightmare. If I cannot understand my own code, doesn't make any sense to me anyway. So Keep it simple. I'm not a super pro. What I'm trying to achieve here is, first of all, trying to get a Jumpman to work, to walk, to eventually to jump, to actually, and then get the collision system to work, and then get the Jumpman to walk around, get on the ladder. That's the ultimate goal. And then we're going to introduce the bad guys and everything, and then we'll try to replicate the first level as close as possible what we have. So this is the target, what I need to do, or what I would like to attain or to get. So other disclaimer, I don't know how much we're going to do, how much work we're going to be doing today. If you have any questions, please let me know. Something I want to say, I posted on the chat, is that Daniel, he's totally freaking awesome, has done a lot of work. I mean, a big step with the IDE that you can go. I posted the link on GitHub. You can download it tonight. And you know, tonight I'm kind of the offender because I didn't post the code. I will post afterward the code I'm creating on GitHub. I'm going to update it every time we do a stream. You can download it and you can use it and run it on his emulator if you don't have a machine yet. The code in theory should work. I think the joystick is there. Daniel is the ID SD card. I think any file system doesn't work, right? Is there a way to actually, if I say I want to load the card, will it work? So please let me know on the chat. Hey Rob, great to see you. So yeah, so we'll begin. I want people to bear with me. I'm trying my best. I will come across bugs that I didn't expect. Nothing is scripted here. It's really, we're going on this adventure of getting this thing to work, and hopefully people will enjoy it. And if it's more fun now, that we could actually, you'll be able to run it yourself and then improve it, make it work, and go from your own direction if you want to improve it and make things. Maybe we can bring your stuff back later. That would be awesome. I would also ask if anybody wants to spin their branch. If anybody wants to spin their version of it, either you copy your own in your own account on GitHub, or you just simply create a branch and you just work out your branch. Okay, so SD card. So I guess Daniel is saying that SD card support for FAT12 and FAT16 in the IDE. So that means that I guess if we add like an SD card because what I'm thinking is that if I want the in the IDE to work to load some file from the SD card, could we do it if we had a real SD card in FAT12? Otherwise, what I think I'm going to do is just join the file with the code for now and just go with that. And yeah, all right. So first thing first, unless anybody has any questions, I'll give you a little bit of time because there's like a few second there's a lag here from me, I would say 3 or 4 seconds. So I will wait for any questions. Okay, awesome. So Daniel says that the ADI is emulating the SD card based on the file system directory of the PC. This is awesome. I guess I'm just going to make the whole thing work first, and then we can go back to the loading of the files. This is something I wanted to do at the beginning, but I think I'm going to wait. We'll stick with the sprites tonight. We'll make it fun. Okay. Yeah, so let's do this. So first thing first, what I need to do is basically what I did last time, but I'll do it only once, which is to run GIMP, and we're going to transfer the file I created, and I will be transferring it in RAW, and that's what we're going to work from, and that should be a lot easier to work from. Only one file. And we're going to do some fast tests to see if we can load any of these sprites individually. Oops. Okay, so I'm going to open, hold on, open, I'm going to go into drive D56 project. We'll go in Jumpman. I actually resigning the demo code for the real Jumpman into my Jumpman senior code, which I'll try to do a game at some point. Graphic assets, Jumpman sprites. I should find a. Okay, so the jump smallest recovery here. This is Sunday. There you go. So here, if I'm not mistaken, let's enlarge the size here. In theory, I should already be in the mode. I should already be in index mode. Awesome. So the only thing I need to do really is to export as. So we'll call it something. I will call it smallest. BMP. Actually, whoops. I will put it in raw, and we're going to export that exactly. We're going to choose BMP style. We're going to do export, and there you go. So we have those sprites. We're going to keep this not too far away so we can use it later. So now what I'm going to do is that I'm going to go into Jumpman senior code, in source, in graphic asset. I'm going to go in Jumpman sprite. I'm going to look that into details. Rob, ETA on the next batch of systems. Okay, so what's holding off the actual first batch of Rev C4B is really about finishing Wiki 2, which is really, really close. We're talking about a week or two, hopefully. And I have, on my back here, I have a bunch of them. I don't know if we can see them, but they're there. And I just need to, because back in the day, I mean, not so long ago, I was still waiting for sound chips. I got some sound chips. I wanted to finish Wiki 2 because the system doesn't come with the JTAG USB blaster. So that would force people to buy one, although I would highly recommend that you buy one because there will be new updates in the future. So I'm really close. Basically what I want to do now is just finish fixing the VDMA problem. Do a couple of things on Wiki 2 to get the collision system a little bit better. And then I think I'm going to be done. I'm just going to do a final test, ship this guy out. Not so long ago, I released, I pre-sold 8 more units. The boards are made. I just need to finish them, complete them, get some, enclosure printed, and these guys will be as good to go. I've made new boards, the green one. Let's see. So I have the green one here. So it's a new batch of, this is a new batch of revision C4Bs. These guys I need to, they're, since I left my job where the equipment was, I'm not working there anymore. I don't have the access to this equipment anymore. So the deal is really to, they were just half assembled, which means that there's a lot of work. Well, there's more time that needs to be put to put the chips and everything. Otherwise, the resistor capacitors are all there. And I got like 10 boards, close to 10 boards made. So when the first batch of C4B and the second batch of C4Bs, the orange ones, are done, then I will probably put more for sale. Because now I kind of have to live off this for a little bit of time, I guess. So this is where we at. So Rob, did you place an order? So while I'm waiting for get an answer, so what I'm going to get here is this guy here. This is the one we want to load. We're talking about, so now I need to know the size of this thing. So what's the resolution? So the resolution of this little puppy is, where are you? What is the, oh, it's because it's in data. Let's find the BMP file. Okay, BMP file, properties. We're talking about, this is 32 by 928. Okay. So here in our code, for anybody who people were not there before, so this is the bitmap so this is the level. So we're going to replace that. We're going to replace that. What we're going to see here is that we have the 124 there, and the sprite here will be, we said 928, right? Yeah, I think so. Yeah, 928. Okay. So the resolution here will be 928, although I don't remember if we're going to, where is it located? I think it's located into the, yeah, we're way above where we should be, so we're fine. Perfect. So I'm going to call this guy Jumpman sprites. I'm going to look for, to replace the old name. I made a mistake here, so here, oh, it's probably not there anymore. Okay, some sprites. Yeah, Dane, yeah, there are a batch of orange board. Do I have one here? Yeah, I can show you. There's really 3 color variation. So you have the black version. You have the connectors going off. You have the orange version, and you have the green version. So these little puppies are, well, the black, there are few left. I mean, they're not for sale yet. I might put them for sale with a red enclosure. I'll sell them more, make like a ton of money with them. Okay, so let's keep going if I want to get something going. So what I'm going to do next, by the way, I know I say the word "so" a lot, so please bear with me on this. All right, so are we, okay, I think this is the right file. Okay, is it the right execution file? Let's see if I'm running the right script. I'm not even sure. So Jumpman code, assemble. So let's see if the assemble. Okay, does it complain? No. Okay, we'll go into the IDE. I don't have the latest version, but uploader, we are on comport 4. I'm going to get into Foenix, Jumpman senior codes. Is that the one today? The 15? Yes, that's the one. So normally, we should see, I'm going to connect, I'm going to send the binary. And for some reason it doesn't want to talk because I might not be on the right port. I don't, why can I connect and yeah, that's better. Okay, so what do we have? Okay, so let me see. All right. So we have the first frame, which is, I think it makes total sense. Because if we go back to sprite, the frame is the one when he's actually. So if we go to the 10th frame, which should be, let's go to this one here. So the 10th frame is the one that's standing up. So let's go back to the code. So that worked. I'm gonna get this off the screen. Okay, that as well. So if we go back in our code, so if I explain a little bit, right now the software, the beginning of the software is 1,000. It's the after the first 64K, the first block of the 65816. So the first 64K, that would be the same 64K in a Commodore 64, 00000 to FFFF, is completely clean. There's nothing. The whole software begins or compile at the address 01, the first after the first block of 64K, and it is laid out right now where it's actually set up to be ran later as a PGX. For the people who don't know what the PGX is, the PGX is a C256 Foenix extension. It's like a PRG for C64, but it's been extended to 16-bit or 24-bit addressing, so we can do like the whole memory range for the execution, and there's an extra byte for revisioning if we want to do something different or different processors and so on and so forth. But right now what I'm doing, or what we've done, is that we created this reset vector where it's going to point towards the reset of the software, although I wonder why it works, because it shouldn't work. This is weird. I'm thinking about it. Anyway, anyway. Maybe it should, maybe it should not. Something is weird. Anyway, bottom line, it kind of starts. Normally, I would create, we would compile this file, bring in the unit, and then just do a bload, name of the code .pgx, and it would load and run, right? This time what we're doing is compiling it, and then we're actually, oh, actually I was wrong. Okay, so the loading address would be 1,000. So we're actually at 4,000. I'm sorry, I was completely, that's why the reset thing works. That's why most of the big data is after that portion of the code, which is the vector reset vector at the end of the first block of 64K. So anyway, so what I do now is that I get into, we're getting into this code. We clear the carry. This bit is like about I think the XC, if I remember well, is the bit to say that we're in expansion mode, like we're in 65.816 mode. Please correct me if I'm wrong. And then we set the DBR, which is the data pointer, data bank pointer to 0, which is where we are. And then normally we would go and set up the DP. Well, these things are like macros. We set the variables, and then the first thing I do is go load the bitmap, which is the bitmap where we see the C256 Foenix. In this code, if I remember well, and this is really to explain, but also to kind of refresh my memory. You know, I'm old and crusty, and you know, I tend to forget things after 3 minutes. Well, you know, 3 minutes if I'm not high, and 2 seconds if I am high. Weed has this thing on me. He's doing this thing on me anyway. Because I'm in BC, we can actually do weed here. Anyway, so what I do is that I set, okay, so I've talked about this before. In the Wiki2 system, we have a bitmap layer in the back. We have a bitmap layer in the front. BM1 is the one in the back. So that's the one that everything else would be on top of. The way it works is that we enable, what I do first is that I set at the beginning the accumulator to short. I decide it's 8-bit. I say, okay, the X and Y will be 16-bit wide. And then the bitmap, we say bitmap enable, so we bip 0 of that register, and we say we want the lookup table 1 to be targeted for this layer, and then we say, okay, the control BM1 control register, that's going to enable it, and then what we do is that the next bytes serve as where the actual bitmap in the video memory is. And as I explained before, sorry for people who were there before, but it's all about the Wiki perspective and the CPU perspective. Well, when we're programming Wiki2 register with pointers, it always refers to its own memory, Wiki's memory. So most people will start their first bitmap bank at the address 0, which is at the beginning. So that's what we do here. We're just setting the 24-bit to point towards the beginning of the VRAM. And from Wiki's perspective, she has 4 RAM and it starts at 0 till 3F, FF, FF, right? The next thing I do, and this is for the bitmap layer, it's really easy. That's all you have to do. Set the address, turn it on, tell it what lookup table you want, and you're good to go. The size of the bitmap will be determined in the master control register, not in the bitmap registers, okay? Sorry. What I do next is I turn off the borders, the vertical one, the vertical one and the horizontal one. I set the background color. The background color in Wiki2 register file is about the background color when you are in graphic mode, okay? Because the background color in text mode is set by the characters themselves. So that's why you can have multiple different background colors in the text mode. The only caveat to this is that when you're on overlay mode, then the background mode of the text overlay is ignored. So only the foreground color is used and the background color is ignored. That's why you can overlay the stuff on top of the, I don't know if it's ignore actually. If it's black, I would have to double check that, but you know, maybe not actually. No, it's not ignore. It's like you need to have the background color for the character to be black, to be transparent, so you can see the graphic underneath. That's the point of having the overlays, to be able to draw text and see the graphic behind. Either you want to use it as a way to display your score, or you want to use it as a debug tool where you can have like a window where you can write what's going on. And we'll get to that at some point, actually. I think it could be pretty useful. All right, so moving on. So when we get to the, after that, what I do is I say, okay, I want to enable the graphic mode, which means that I'm turning off the text mode. I'm going to enable the bitmap mode, because turning the graphic mode, just say the graphic engine will be turned on, and then within the graphic engine, there's multiple blocks. The idea of having an enable for each block is to have, let's say, for example, if you say that the bitmap mode is off, then the graphic engine doesn't spend time to see, hey, is there data for the bitmap? It doesn't even bother, just bypass it. It's okay, it's not on, there's no point, because I explained that again last time, I'll do it again. We just have a certain amount of time to go capture the data during the previous line before it can be displayed the next line. The engine, the memory works 100 megahertz. During that time, we're going to fetch all the graphics for the bitmap, all the lanes, all the planes for the tiles, all the sprites that are on the same line. So this is really important to understand, because when you're starting to do like multiplexing and stuff like this, you need to take that into consideration, where the data that's being displayed at X line is actually fetched in the memory at X line -1. So this is how it works. So we have a set amount of data, set amount of time. So if you're going to fetch a bitmap, if you're going to fetch the 4 tiles layer plus the 32 sprites, you'll be pretty much at the limit. And I have to be honest, I never tested it. I calculated it. It should be fine, but it's possible that the last sprite might be not even displaying, because then you'll run out of time. That's going to be tested. Something else I thought about would be to enable more sprite to be on the same line, depending if one of those blocks or layers are turned off. Because if I don't need to get 4 lanes, not 4 lanes, but 4 planes of tiles, then I have way more time. So then instead of having just 32 sprites that I can load, I could like load 48 and so on and so forth. If you're only using 2 tiles lane, then you could maybe do 64. I don't know. That's the game where I could modulate the amount of resources could be attributed to a certain block depending of if one of the other blocks are turned on or not. So in that case, what we do is we say we need the 1 bitmap layer, we need the sprite block enabled, and that's what we do. The second line is about the master control register high is to determine right now the only bits, the first and second bits are used to determine if it's going to be 640 by 480, which is when it's 0, 0, 640 by 480. If you put the value 2, then you'll have doubling of the pixel, means that you're dividing the 640 by 480, then you just have a quarter of the memory you're going to use. So if you use a bitmap, instead of using 640 by 480, you're going to use 320 by 220. But the video timings are still 640 for the display. It's still 640 video timings by 480. It's just that each pixel is doubled vertically and horizontally. If you put the value 1, then we go from 25 megahertz dot clock to 40 megahertz dot clock, and the video timings change. These are hard-coded. It's just a simple bit that just sets switch. All the video core is resetted, and then everything is set for 800 by 600. And obviously the double pixel mode just divide everything by 2, which makes the pixel bigger, 400 by 300, which I think is a great resolution to do gaming, because it's a little bit bigger, it's a bit smaller than 320 by 240, and you have a little bit of room, but it's still not 640 by 480. Yet it's not completely, we have not used it a lot so far. I hope we're going to use it more later. Something else also to know is that there's a bug with this is a part bug with the PLL when we're switching from 25 to 40. So when we switch, there's a control register that we can switch the value of the PLL to 25 to 40. But when we go back to 40 to 25, we have to toggle the bit kind of twice. So instead of doing 0 to 1 to 25 to 40, when we want to go back, we have to do 0, 1 to 40, and then we have to do 0, 1, 0. And that's how it comes back to 25. If you just do 0, it's just going to stick to 40, and then the timing will be for 640 by 480, but the speed will be for 440 megahertz, which will end up having your screen to tell you that your monitors are sync. So it's important to use the kernel calls to change the resolution if you don't want to have any problem like this. All right. So I know I'm spending a little bit of time on this. I don't know what I did here because it's all weird. Okay, it's me. Okay. What I do next is that we are going to transfer the lookup table of the sprites into the lookup table 0. We're going to transfer the lookup table of the bitmap we're going to use in lookup 1, and we are going to do a simple branch. This is the easiest way to do it. The lookup table is 1024. It's 256 bytes, and there's 4 bytes. There's the alpha channel that is still there, and I'm still debating about though. I thought about if I had time, I would probably put like a transparency mode for the tiles. Still thinking about it. We'll see what I can do. I need to finish everything else first. Anyway, moving on. What I was doing here is literally transferring the sprite data to the video memory, and so now I have. Let's see how much this thing will, how big this thing will be. Let me get the calculator. I like this calculator, although I wish it would be a voice activated calculator so I don't have to click it every time. Okay, so we have 32 pixel by 9. Oh, for fuck's sake. I told you, my memory is so bad. I'm just like, I'm really, 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 really bad. Let me see. All right. By 928, I think. 928. All right. There you go. So 32 by 928 is the data we need to load, which is 7400. All right. You gotta love that stuff. 740. Okay. So we're back here. 740. So that would load the whole bank, all the sprites. So let's assume it's going to work. It should. Hold on a minute. Okay. 740 bytes. We're going to jump, transfer it, and then what we do is we transfer the 64K. The next part is about the bitmap. This is bitmap transfer. Bitmap transfer for the first level. And then the second level is, this is the second part because the size is bigger than 64K, so I do it in two parts. So the overall size is 012C, 012C00. So we do the first 64K here, which is 0FFF, actually 100. And then we do the 2C here. So for people to know what's going on. And you can see it here. Okay, so after this, the sprites are transferred, the bitmap is transferred, and now it's time to set up the sprite. And we say, hey, we say in the sprite configuration register, there's many things. The lookup table you're going to use, you have to enable the sprite you want. So in the block for the sprite 0, and again, sprite 0 is the one that is the most in the front. Sprite 63 is the one the most in the back. So what you have to do is tell it where in between the different layer you want to have your sprites. I mentioned that last time. It's important to realize that for the collision system, this is just a note. I'll probably talk about it a lot more eventually. But you cannot, the collision system won't be able to detect the sprites on the same level. So it's important to consider that when you're going to have protagonists in your games and antagonists in your games, that if you want to have collision with your antagonist, it's important to put them on a different level. So at that point, then we can do a collision between, your hero and the bad guys, which, most of the time the bad guys turn out to be the real hero and the hero are just, losers. But that's beside the point. I'm not just a note like this. I always thought that Thanos was more a hero than the Avengers, but I'm not going to go there. I wouldn't want to, leave all the people watching right now. Okay. Normally here is the target where we want the sprite, which data in the memory we want to target to be displayed as a sprite. So we're going to calculate. So if we have a sprite 32 by 32 and we want, oops, I'm in the wrong system. So 32 by 32, which is 1024. And we want the 10th sprites, so it would be 10. Yeah, so if we put that next, so 2800, so we're gonna put 2800 here, and we should have the 10th sprites. The location of the sprite, we're gonna leave it here. I think we're gonna bring it back later. I think it makes more sense to just place it and see if it works. All right. By the way, these guys we're gonna remove. We don't really need. Not anymore. We'll come back to that later. Okay, so otherwise in the source file right now we have the because I also put the code to see the little Jumpman splash screen at the beginning. These are the colors, Commodore 64 color palette for the text character, and I'm also creating, you know, there's data to see the character on screen. We'll see that later. I don't think we're gonna even bother with this today. Anyway, so I'm going to compile. I'm gonna bring this down. I'm going to compile. Everything seems to be perfectly perfect. We're gonna go back. We're gonna reset the machine. I got my machine to be a lot closer this time. We go back into the IDE. Bring back the IDE here. Actually, I'm just gonna bring the loading part of it back. We're going to Jumpman, and it doesn't work. Wow. Okay, that's really cool. We have garbage. Oh, that's interesting. Dane, I'm sure you liked my comment about Thanos, huh? Yeah, he's great. I thought what he said was really meaningful. At least it spoke to me. I thought the Avenger were the one that couldn't let go. Yeah, human beings have problems with letting go. Okay, so it doesn't work again. Am I doing something wrong here? Okay, you know what? I'll do something before I go crazy about things here. I'm going to remove this because this is part of the debugging we did last time. I'm going to put back this to 0. I'm going to recompile it. I'm going to retransfer it. I'm going to reset again. Probably in the IDE would be even better. The color of the garbage is right. This is funny. Okay, this is great. We got nothing this time. This is pretty awesome. Holy crap. Okay, so we have the right graphic. Okay, so the first is good. I'm just, am I missing something here? So normally, if it was logical, if I put 05040, that means we are at the end of the first one. So we'll do it again. We'll try that again. And we're gonna dump it again. I love that process, you know, it's very okay. Well, this is not satisfying. This is really okay. You know what? We'll go and see the listing. The listing. Yes, this is the listing. I want to see the Jumpman sprites. Am I loading everything normally? If I look into the, I know you don't see much. Okay. Okay, something is, no, that's a lookup table. Okay, there's another one. Okay, so that's the first graphic. Okay, so, okay. Let's move back to where we were. Keep that here. Let's put that aside. You know what? No. Something is wrong. Very wrong. My size is too small. That doesn't make any sense. 32 by 32. No. 32 by... No. 32 by 928. Divided by 400. That's 1D. Oh, yeah, of course it's wrong. It's not 740, it's 7,000. Yeah, no, the size is wrong. I'm such a klutz. Okay, let's recompile this. So I didn't barely put enough. And what we're going to do here is reset the damn thing. If I can transfer a bitmap, I think I can transfer some files, some sprites. Okay, is that a little bit bigger? Yay! Okay. So is everybody still there? All right. Now, is it the right size now? Yeah, I think so. Okay, so where we're gonna go at the 10th. So 10 times, so we said what? We said 10 000, I know I speak French, right? 10,240. No, c'est pas ça. It's 1024, this, no, I mean 32 by 32 by 10. And this is 2800. Okay, I told you my memory is so bad. Okay, we compile this again. It's awesome. And then we're going to reprogram the little bugger. Okay. And we should have a jump. Yay! It's not the right. I should have put 9. Okay. Okay, we'll put 24. All right, so that should work this time. Okay. It's I know it's really, trial and error type of thing. Okay, yes, success. We have a freaking Jumpman on the freaking screen. After an hour. Okay, this is what we're talking about. Okay, the sprites are there. The index is right. Well, the index is right. Okay, so what I would like to do now is to... okay, let's see where we could put this little bugger. I don't know how I'm going to go about... You know what? I know exactly what I'm going to do. Because I'd like to put it in the... on the platform. Well, we could put it on a pedestal where it needs to be. But in order to do this, I will need to have the... this one. Okay. So if I go in as sprite, the sprite here should be the location. All right. So I should be pretty much in the middle. So 160x, 170y. Yeah, 160, 170. We're going to go back here. Hold on. 170, 160. You know what? I'm not that far for where it should be. 160x. 160x, That's weird. Something is not right. Am I missing something here? Or it should be divided by 2. Oh, probably it's divided by 2. Okay, divided by 2. So I should be here. So 80x. No, doesn't make any difference. No, hold on. Hold on. Okay, all right. No, this is 160 is the X position. Again, I'm such a klutz. Okay, so the the 0 is not at the bottom, the 0 is at the top, so I need to be 170. Okay, because the 0, 0 is at the top corner. So let's go back as bright. I just want to make sure I put it like it's straight in the middle. However, I'm going to put it offset a little bit. So 320, it should be 160, but the sprite is 32. I want it to be in the middle, so it's minus 16. So normally I should have 160 minus 16, which should be 144. Nah. 160 minus 130, 16, 144. You know, I suck, but although I don't, it's going to be weird. Anyway, let's do it. Let's recompile this. And just for fun, because we like to have fun, okay. Why is it offsetted? Oh, I know why. Duh. Okay, so this is something very important. Okay, the 0, the origin of the sprite is at the top left corner. And the origin of the sprite is always going to be at 0, 0. It's off screen by 32 pixel. Because when you want to get it out of the outside of the screen, I needed to put the 0 origin outside. So if you want it to appear at the upper left corner, it needs to be at 32, 32. This is where it needs to be. So obviously, if I want it to be at 144, I have to add 32. So this is really important to have. You have to add this offset of 32 to get it to be in the center of the screen, which is 176, which makes way more sense. So now that should work. Something to take into consideration. And it's a bit confusing because the tile system has an origin outside, but it's not 32, it's 16. So we'll talk about this later. Like a lot later. Okay, so we go and do this again, like we've done this before. And it should be straight in the middle when it starts. It's very temperamental tonight. Okay. Okay. That's an interesting one. I didn't apply that same thing again. That's interesting. Because this one should be also 32. Okay, let's go back to the picture. Okay, so it should be sitting, okay. But the origin is 32. The origin is 32 above. The origin of the sprite is at top left corner as well. So the little 32 by 32, its origin is at the top. So when you're moving from that point. So what I did is that I said go down at 1. Oh, no, it works. So I said I would like you to be at 170, thinking that the thing was at bottom, but no, it needs to be 70 minus 32, but you have to add the 32 offset because it's underneath the border. So I guess we're talking about 1. So we'll have to take that into account later. I don't know if everybody's following me here, but yeah, 177, no, actually, no, so this is good. This is 1. Yeah, well, that seems to be the case, or I'm offsetted in some way or the other, but at this point it's relevant. Okay, this is final call to, let's see, no, that's not what I want. Did I turn it off? No, it's here. Okay, so this is final destination. We should have a Jumpman straight in the middle, and then we can start having fun with it. Okay. Well, normally it should appear, but we'll do that later. Okay. So we could actually start with that. Okay. So we are going to start doing something interesting. This is where, so this is just having one sprite. And like I said, what we're going to do, I think the first step will be to, and what I'm thinking here is that I'm going to go get a 64 task manual. Is there actually a PDF version of this? Oh, there you go. Okay. This is, I'm going back to the manual because I'd like to, this is because I'm kind of rusted a little bit. So I want to find about the tables, how to create tables of, not tables of contents, but, or array, or, so I would go about and trying to find, I'd like to create a table of addresses. A structure? No, not a structure. How did I do that last time? Yeah, Daniel, I know it's late, 4 hours ahead. Yeah, you can watch the rest later. Thanks for your help, dude. Enjoy your night. Sleep to sweet dreams. Okay, so what I'm trying to do here is create a table of addresses. So the only thing I need to do is pull an index and tell me exactly where the, I mean, I could calculate it, but I would rather just go through the list. So normally what I would do is create that table, and I'm thinking about a way to get there. How did I do that last time? Let's see if I do array. If I would spell array the right way. List and tuples, array. Yeah, that would work. Okay. I told you I'm as dumb as some. I like example. I work with examples, so much easier. Yeah, you know what? I think I know. I just need to know the form. Is it like, do I do that in for 24 bits, or I think it's, what is the type name for 24? Like I said, I could probably, okay, so what I'm going to do is create a table exactly like the one we're seeing right now. You know what, I'll put it here. Do I want to put that there? Okay, we'll make sure that nothing I do will. Okay, so we'll sprite appear sequence. I will say it's not text, it is what's the address? 24-bit address. It's not text, it's long, I think. I could probably do long. There's byte, I think there's short. Because there's long. Where's long? The word? Address maybe? What's the address? No. Address is word is 16-bit. Byte is 0 to 55. Char word is 64K. I think it's address long. Long is 24-bit, so we'll do long. Yeah, we'll do long. Okay, so dot long. I would say the sequence. I will bring sprite here. We're going to look at the so what I want to do is literally forget. So the first sequence is sprite 0, sprite 1, sprite 2, sprite 3, sprite 4, sprite 5, 6, 7, 8, 9, 10. Okay, so the 1 to 10 is the appearing sequence. So, like I said, I could literally take the pointer and say if I want 0 to 1 to 10, just multiply it by 1024, we would be done with it. But what I'm going to do is just say that I want the first sprite, the index in the table will be 0, 0, 0. And I will just do it. You know, we have a lot of data, so I'm not going to bother myself with calculating stuff if I want to have to. 0, 1, 2, 3, 4, 5. Everybody is okay? There's only 5 people. Hang in there, guys. So 5. So 0 to 9, so that would be 400, 800, C, 1, 4. So who thinks here that Thanos was the real hero in the whole story? And be honest. Don't shy away from, it makes sense. 2, 4, 2 8s, 2, 4, 2 8s. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't need these guys here. So anybody on the chat who wants to tell me that they thought that Thanos was right? Okay, so this is the sprite appear sequence. So these are the offset in the memory. Actually, I should make my life even easier by just adding the I address so I don't have to compute it. All right, Dane, I'll try to make it maybe earlier, maybe next time. I'm busy, but I'm trying to fit it in my schedule. The weeks are, by the weeks, as the more we go further in time, the more time I will have to prepare everything and be ready and, like I said, do it a little bit earlier. But yeah, don't worry, you can watch it later. There's, 40 playbacks now? So, you're good. So, I'll also try to put some bookmark. Oh, Thanos is a eugenicist. That's interesting. Yes, he is. But the concept, the philosophy behind what he wanted to do made sense. if you remove the aspect of um, the whole emotional connection with everything. You know, human beings tend to emotionally connect with everything, and then if you connect too much, then you just feel the sense of loss, and nobody wants to lose shit, and then you go through the process of grieving. It's painful, so obviously people don't want to do that. But if you look at the concept itself, because it was supposed to be impartial, and that was the idea that I thought was really interesting. If it's impartial, I mean, that includes you. Of course, like if I'm the one to kill half of the population, that includes me, but I think he accepted his fate, right? So I'm just saying, there's a part of it, the part I enjoyed about it is the fact that he was actually sensitive. It's like, if you remove the aspect of being rich or poor, or, you know, it was impartial. I thought it was interesting. I connected with the idea. But the thing in the story of the Avengers is the fact that the heroes that are supposed to be like these, you know, higher level type human beings were all like, we cannot let go, we cannot let go, we cannot let go, we cannot let go, which is a very specific traits of things we have a hard time to do, which is to let go, let go, let go, let go. And I think a hero, among other things, should be willing to let go. It's like seeing the wisdom of letting things go, the physical aspect of things and the emotional aspect of things. But again, this is my point of view. I know I come across a bit, you know, heartless when I talk about that stuff, but, you know, obviously when you talk about it at large and you don't mention any, it's not like I would enjoy losing my child to that kind of stuff. But, you know, losing my child to an accident of car, losing my child to a Thanos accident is the same thing. There's loss, and you have to deal with loss. So it's not fun, obviously. So I get that point. But I'm just saying that being a hero and all, you would expect these guys to be, you know, have a little bit more wisdom and realize that, okay, you know, let's try to be better. Okay. So sequence 11. So let's go through sequence. So there's only 2 sprites for every you are rebuilding the C64, so there's a heart in there somewhere. No, there's a heart. That's not the problem. No, I have an issue with not letting go. People attach themselves with everything. People need to learn to let go, to detach themselves emotionally. That's why people are so easily controlled. Because let's say you have a car, you love your car, and you love it like you would die for it. Well, you're so connected emotionally with it that I can use your car as a way to manipulate you, right? I'm going to threaten you about scratching your car, and I'll say, well, you're going to do that for me. So you see, I'm controlling you because you're emotionally connected to your car. If you were not connected to your car, and I said, I'm going to scratch your car, and you say, go fuck yourself, I don't give a shit, then I don't have any control over you. You see what I mean? This is why I feel that people nowadays are too attached to their shit and too attached to everything that happens in the world, because something that apparently doesn't come across is that we don't have any control over anything. So why do we get so emotionally involved with things we don't have any control over? And we're fooling ourselves believing that we do have control when we don't. The only thing you have control over is yourself. You see, so there's a lot of things happening in the world today, and we feel like responsible. We feel that we should do something because we have an emotional connection. But in reality, we don't have an emotional connection because we don't have any control. There's war in part of the world. What can we do? Aside of actually going there and try to kill or try to fight it, there's nothing you can do. So why do we get all riled up about it? And then when we say, oh, there's this thing, and we, no, don't do this. It's like, you see what I mean? That's what I'm talking about. Detachment is something people should learn to do. Because at the end of the day, when you die, you don't bring your shit with you. And then, yeah. Okay, so there's only, the good news is that there's only really 2 sequence. This, I don't know if somebody can tell me when this figure, we see this figure in the C64, when he has like a step like this. Oh, I know the chord. When he's going down the chord. I get it. Okay, so the 12 sprite and the 13 sprite is going left. So going back, that's gonna be easy. All right, so basically what we need to do is sprite walk left sequence dot long. We're talking about, oh, I forgot to put all these guys here. So this is, normally would probably be a better idea to just add up the offset if we are going to move the data somewhere else. But for the sake of the test today, we're just going to add it up. So this is the absolute address of the location of the data of the sprite in the video memory. All right, so we're going to do the same here. We said that this is sprite number 12, which in reality would be 11 because we start at 0, and 12 and 13. So 11 and 12. Sprite 11 and 12. So 11 times 10, 24. So that's 2C, which makes sense. What happened to 28? Oh, 28 is the guy who's climbing up the thing. Okay, so 2C, 052C, and then 0530, 3000. Okay, so this is the walk cycle. There's only 2 steps. Easy. Right sequence. We're gonna go walk right. We go back here. We did okay, 14, 15. So that means that it's 3, 4, and 3, 8. What else? Might as well do the others. So the jumping left, 16. Sprite jump left. It's not much of a sequence at this point. Long 05 4000, no, 3 C's. An end sequence marker. Well, the thing what I'm going to do is I will do another index. So what I would do is probably, yeah, I could do this. So 3 C's. And here that would be 4000. Okay, so there's many ways to go about this right now, because in terms of knowing for which sequence has how many, I think right now we can embed in the code itself how many sequence there are. By the way, there's only one. I think I went too far here. There's only one. So 16 is the one on the left. 18 is the one on the right. And I think between, so I'll do the calculation. So I said 16, but it should be 15. Because we're starting at 0. 3 C's, so that's cool. And then that would be 4. Oops. Okay, so I'm gonna come back to this. So sprite. Again, I'm making it really simple right now, because later I think we'll have to add the, where, like a structure, like a velocity, the position, all these things. I really want to just play around tonight. I'm not going to do much. Oops. Okay. I'm doing some kind of house cleaning. I think I'm going to stop there. So this is to go up this stair. This is the rope, and the fall. Okay, so we're not gonna fall today. So let's stay this way. So what I think is what we could do is that we could literally create a variable. Okay, so I'm not a stack person. I don't use a stack a lot. I hate the stack because, you know, one thing that goes wrong in the stack just blow everything up. I just hate it. People like to do C-style programming in assembly. I don't. I'm a page zero fan. I love to write my shit in page zero. I like to use the ability of the page zero, and that's what I want to do. We're dealing with, so we'll have to deal. So I will declare a variable in page zero for the X position and the Y position of the sprite. What I think I would do is literally just write a piece of code to for each sequence, and then would basically just have a read the joystick, and depending on what direction we're going to go, we're just going to run that sequence to move the sprites with that specific sequence. At that point, I'm not sure if we're going to get there tonight because we need to instantiate the although I could put the interrupt, although we could do it in the loop, in the main loop at this point. I don't think it would make much difference. We could put like a delay or something because it's going to go way too fast. That thing was going to, you know, go around like crazy. All right, so what I would say is that we'll start by creating just a sequence, opening sequence, where the sprite just, so on that case, the only thing we need to do is literally going through each sequence, appear sequence, and we just have to put a delay and just go through the sequence, and then we're done. I think this is the easiest way we can go about this right now. And then when we're done, then we could go into a small loop and then just go and create a walk cycle sequence and then go to the other side. If anybody knows Jumpman enough to remind me when he was in idle, so did he come back straight? I guess it would. Okay, so here's the plan. Let's start with the sprite appear sequence, and what we're going to do is just we're going to go through this sequence, and you know what, I'm thinking about something that should ease our way into this, which is dealing with 3 bytes of sequence is a pain in the butt. So I think what we're going to do is that set our pointers to 32 bit long, so D word instead of long, because then when we want to go from one pointer to another, then it's a lot easier. We use a little bit more space, but you know, 4 megs, I think we're good. I think we're gonna survive that sequence. That you know, the fact that we don't take so much memory. We take so much memory anyway. You know. All right, give me 2 seconds. I need to eat something. I'm starving. I'm gonna eat some Doritos. No sponsorship here. Okay, so what I just did there was that for any address space, it's going to create a 4-byte entry for the 24-bit address, which will be a lot easier to go fetch when we, you know, if the index says 0, we're going to go at the first one. If the index says 1, we're going to do a second one. It's a lot easier to move from 4 than for 3, because we just can do like an SLR or just move the bit of the counter and move on. All right. Let's move on. At this point, guys, any questions? Okay, let's start with the appearing sequence. Okay, sprite. in in 64 tasks, there's this command or whatever. .pros means you open a procedure, you close a procedure, which means that all your variables used in this will be used only in that procedure. So, which means that you could use the same name for your branch name. For example, your labels for your branches could be the same branches names every time, considering that every procedures is its own little world and they're not shared with the others. So this is something anybody who's used, nobody, if you ever use task 64 tasks before, so this is the way to isolate the context from everything else, which is probably a great way to avoid having any, label, problem. We wouldn't want that, right? Okay, so the first, so normally I would say that I would probably want to initialize the position. You know what? Before that, I wonder if I have a. I think that I will. I'm thinking about setting up my variables in the page 0, so I just want to see if I have already like a definitions file that already. I think not. Maybe yes, not include. Okay, so there's already these. These are the variables defined into the kernel space. Although we're not using the kernel space, since it's completely individual, independent. So what I'm going to do is that I know from. I will steer clear of the kernel basic stuff. So I would start at 26, which are the operator that we really don't use anymore. So what I'm going to do is just I'm going to use these guys here and put that in my software. I'll put that at the beginning. Maybe later I can like embed them into a different file. For now, I don't want to go from one file to another. Variables, this is like temporary. When they're like a lot of them, we'll move them. Okay, so what I would say was I would say that Jumpman X position. Oops. Although I could. Yeah, it's because at some point I think it's going to make sense to have the interrupt deal with the update of the position. But for the sake of the process, we'll just keep it that way. So I'm keeping, so this is like 16-bit value for X, 16-bit value for Y, and we'll live with that. I would say Jumpman. We'll keep like a location for the sequence number if we want to save it. Again, I could use push A or pull A, but I don't know. Could do just a simple index would be sufficient at this point. You know what? I'll just keep the position for now. I don't know why I would start them in it, but we'll go there. We'll start there. Because the idea, what I want to do is that there would be, I'm not sure if I want to set the position or drive the position register in every piece of code I'm going to use. I would rather have a variable be changed and then there would be a code to update the position of the sprite itself. So we just call one call to just update the position of the sprite as opposed to just have the same code repeat over and over again. And I think it makes more sense. It's faster. So let's do it this way. I should have made a copy of this so I can bring them into, like I said, my memory is like very, very tiny. It's very tiny, so I tend to forget really quickly. Okay, So I'm going to put them okay. So what I want to do now is literally, so what I do usually is that I don't bother myself. I really set A to be 8. I set X to be 16, which is usually the case. I will do an indexed. Yeah, I can do an index log at this point. It doesn't really matter. Okay. So the idea is to load. What I would do is literally, we'll start with the sequence of loading each address and setting the address of the sprite. And again, that could also be set into a different variable and then updated only once in one place. But we'll do it like crudely tonight just for fun. So in that case, there's two aspects of the sprite we need to do, which is the first aspect is to literally program these is to update this one after the other for every sequence. So it is, we load the pointer of the graphic, we assign it to the sprites we wanted for it to show. And besides, that type of thing should be done in the interrupt when the start of frame, so we don't see any glitches in it. But again, tonight we're not going to do this. So what we're doing is really loading the index, loading the absolute address of the graphics we want in the sprite, setting up the address in the sprite, having a delay, then go back into loop, go get the other one, and then having a delay, setting up, having a delay so we can see it. It's probably like a half a second or something, and then we're good to go. We don't have to, bother ourselves with, stuff like this. But again, I think all the register update and some of those registers update are hardware. You can actually change you cannot, like for example, the scrolling of the tile is updated only at the beginning of the frame, which means that it's hardware encoded. You cannot change the scrolling of the scrolling mid frame because it doesn't work. I tried. It just makes everything crazy. So the sprite, I think you can change middle frame, so you could split maybe. I don't know. Difficult to say at this point. All right, so moving on. All right, so the deal is, what I want to do is I want to set my X to 0. We're going to use X. So what we could do is literally and simply say, hey, we want to have this guy here. And again, very, very crude what I'm doing here. So don't jump on me. So if we do this like this, we say, hey, we're going to take the first byte, although that could be local, but I'll still put it long. We put the first byte, and we're going to put it here, and we're going to use this guy, +1, and we're going to do this like this. I'm going to say +2, and then here, so that means that this is going to change the graphic. Update. So 0, we update graphics. The fourth sprite is, so that means here we would have to increment X for time. All right, at this point, since I'm not, so there should be a call, there should be like a GSR for a pause here, like maybe, I don't know, We'll put a timer. All right. So just to see who's still here. Anybody wants to say something on the chat to see if anybody is alive? Who's alive? Who's still here? Speak out. Okay. Again, very crude way to do it. Kyle, you still here? Great. Okay, so we are, again, very crude. So this is, so that would be 4, 8, C, 16. Raise his hand. I'm alive, John. Awesome. Great, guys, to have you here. Awesome. Okay, so 0, 4, 8, 12, 16, 20, 24, 28, 32, 36. So I guess we're going to compare it to 36. Very crude way, okay? So don't beat the shit out of me because I'm doing something really crude, but it should work. I mean, the sprite is already, there's nothing fancy. I need to work it out. I need to work out the details and try to make it a little bit more fancy. And since we almost like an hour 45, we'll get on with this. We'll try to make it fancier over time when the needs arise. RTS, I guess. We'll keep it local. So the only thing I need to do now would be to, and then I need to, so I need to keep my X. Okay, so I'm gonna push X. I'm gonna pull X. Somebody who said that I was not doing any stack, I kind of have to do it now. Yeah, I know, right? But you know, it's where you. This is where you have to fight with yourself about how the code should be clean. Hey Norman, it's about how. I mean, I make it really quickly because it's a lot easier, a lot faster for you guys. Otherwise, it's just a lot of time watching somebody just trying to make it fancy with indexed with X and Y and all these things. I could make that really fancy, but I don't want to. I just want it to work, okay? Go down to brass tacks and just make it work. We just see the freaking Pac-Man. I don't know why I keep saying Pac-Man. The Jumpman appear, and then we can go from there. Again, I think we're gonna come across some really serious problem at some point, but all right, so I push my X, I pull my X. So I pushed it in 16-bit. It needs to stay in 16-bit in the pause routine. So I'm just going to create a pause here. And to be honest, I have designed a, there's a timer block, and I never really used it. So that's gonna be fun. I've explained to people many times how to use it, but I never really programmed with it. So that's, yay! Okay, set AS, again, force of habit. Okay, let's load the timer def, which is here. All right, so we're gonna use a timer block to create a delay of 250 milliseconds, which should be easy enough. So the first step is really easy, is to know how many counts we need to reach 250 milliseconds. So normally you would go about saying the frequency of the controller, at least now, the frequency of the timer, I'm saying that now because there was a time where I wanted to feed the timer block either with the 14 megahertz of the CPU clock, or to use the starter frame clock, which is 1/16 of a second. So you can't count how many frames are passed before doing something. which I might do something like this at some point. There's only 2 timers. Maybe I could have had another one and have this one having the clock of the SOF as a clock source. So you could count how many frames have passed before doing something, which could be useful. Anyway, I'm trying to make it as useful as I can. So we'll go into scientific mode because it makes more sense. We have 3.1818, 0. So this is the clock frequency of the CPU. This is the exact frequency of the CPU. You invert it to have the period. We're going to save the period. And now what we want to do is we want to know how many times, how many clock cycle is there in 250 milliseconds. And we divide by the memory, the clock. So that means that we have 3 million, which is 3 point blah, 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 blah. So I copy this. I'm going back into programmer mode. I'm bringing this back and I'm going in X. And this is the countdown I should get for it. You should have added an end frame. Frame sequence. Yeah, that's the thing. We talked about this. Right now, I mean, since it's not very complicated, I mean, the appearing has 9 frame. The walking cycle has 2 frame. Definitely, we could put like an extra byte and say, hey, this is the last one. We don't have to bother ourselves. I get it. Again, I'm trying to make it really, really bare minimum. So I know the amount of sequence there is. So like I said in my disclaimer at the beginning, I'm very literal and very absolute. These bytes and end of sequence type of thing are when you actually go and do it and try to make it as flexible as possible. This is not flexible by any stretch of the imagination. This is very hard-coded. But it's just about, since it's the appearing sequence, don't need to bother myself too much with this. Anyway, so if I'm going back to the timer, so I'm going to put like my value here. So this is the number of clock cycles to reach a delay of 250 milliseconds. So right now, obviously, we don't have anything to do. We just want to get the thing to appear one thing at a time. Very simple. I assume the weight's meant to be, yeah. Very simple. Just get a delay. I mean, I'm taking all the CPU time to just do nothing, just grab ass. That's it, okay? Very simple. There's nothing else to do. Maybe later, while the graphic is doing something else. Again, most of that stuff should be in the interrupt routine, and the state machine interrupt routine will come with that a lot later. I just want to get something moving for the sake of showing something. And we psychologically speaking, I think it's going to make a lot of sense, and it's going to be a very, what's the word they use all the time? Like bringing a lot of contentment, like, yeah, something is moving. We're going somewhere. We're going places. It's going to be great. Okay, so I'm going to switch between the timer module. Oops. So what I want to do is, you know what? Oh my God, I'm full of thumbs tonight. Okay, so I'm going to set up the so I want to turn on the timer 0. I want to, I don't need to clear it. I want to load it. But before I load it, up, down, it's going to be a down. Maybe I should load the value before. Okay, again, super crude, super fast. So we're talking about, I'm just going to even do it in bytes, which is really timer 0 charge. Super long. Hard-coded, nothing fancy here. Very, very basic. So medium, high. So 999E36. So this is the value I'm putting into the countdown counter, the charge. So you're literally giving a value. This is the value that will be counting down to 0. And when it reaches 0, well, normally we would have an interrupt, but I think I have a comparison register that I can compare. Actually, I could set up the compare register. I'll have to pull this one. Can I have to? Okay. To cycle when counting dust, set to reload when counting down. So timer up down, I would say that the down is 0, so I don't need to set this one up. Enable. Yeah, the timer control register should be done at the end. But what I need to do is to see when it reaches 0. My God, because normally the timer is triggered with an interrupt. Although I could check the. No, I know exactly what I'm gonna do. Okay, so the compare register, we're gonna keep it to 0 because we're doing a countdown. So what I'm gonna do is load 0, start STA. Obviously, that routine could be a lot more flexible. Like you could use it to do delays of any sizes. I get that, okay? Again, we could put like those values in page 0, just set up the page 0, call that thing and be done with it. And that's probably what we're gonna do at some point. But let's start with that. Load compare with 250 millisecond count. And so what we need to do is at that point when everything is loaded, you do time load, you enable the timer, you load the timer, you charge the timer with the value you want, and then you literally, let's set to 1 for it to cycle when counting up. In the compare register, you have bit values for it to do it again and again. So if you want like a frequency to interrupt constantly. The deal is with the timer, what you do is that you pull the interrupt registers to see, without creating an interrupt, you can keep the mask off, but still pull the the timer interrupt to see if it happened. So hopefully it's going to be without too much pain. So since we're counting down, we don't have to bring this up, so we're good. We don't need to clear it, we're good. So I think we're set up. So the first part is good. So the deal here, enable the timer, and it's a one-shot countdown. Okay. At this point, the timer will be counting down. What we're going to do is going into the interrupt definition file. Let me see if it's there, interrupt def. And what we're going to do is load the pending register. As you can see, there's like a lot of sources for interrupts. What I need to do is really to look into interrupt number 2 of the timer register 0, which is the pending register here. So what we do is normally it's going to be 0 till it reaches this countdown, and then it's going to go to 1, and when it reached 1, then we know that the timer is done. And normally, the mask stays off, so it doesn't actually create an interrupt and go to the interrupt handler, into the RRQ handler. At this point, we have not changed the interrupt handler. We're going to do that later, where we're going to, commandeer the interrupt reset sequence and change the handler to go in our stuff. Yeah, well, it's Kyle, it's pretty low level at this point. Very, very low level, but you know what? We have full control. Nothing virtual in between what we're doing here. Okay, so in the timer, so I go back in here. So what I'm going to do here, do a simple register. I'm going to end this with the timer 0. Oops. Okay, so we're going to end this with the inverse of this. Is that it? No, we're going to end this with this. So we are going to end it. We're going to compare it to it. And if it doesn't branch, then timer is not done. And I guess at this point, when we reach that point, RTS, I guess, we're going to turn it off. We're done. We don't need to do this anymore. All right, so if I recap, I set the charge, which is the value that the timer will be counting down from. I will, the comparison, because the timer is also with a comparator, and if you do a count up, then you would have charged the count up with that value and say, okay, count up. So you can do both, doesn't really matter. It's your preferences. I think I should have just implemented one, but I implement both. So you can either put the comparison with your value you want to reach. You start from 0, you go to 0, then you reset back to 0, to that value goes back on and off and on off. You want a recycling frequency. Like, for example, I don't know, you have your music. You want to have to play each note at 1/16 of a second. Then you set it up as a recurring interrupt for your sound player. Depending on the beat, of course. So Daniel's tracker is using that method. I mean, obviously you could use the starter frame, but the starter frame is only 1/16 of a second. So if you have your beat is an odd beat, then you cannot reach that value with this. So you have to do it with the timer. Then we load the timer, we load the charge with the value, and we say enabled. The count up and down bit is 0, which means we're counting down, which means that by the time we reach that value of 0, when the comparison reaches 0, we should have an interrupt generated, but we're not going to respond to that interrupt because the mask is off. I sure hope we're not going to go there. And then something else we need to do is also clear the value. So we're going to do this like this. We're going to clear the pending interrupt so it doesn't stick around. All right, so Dane, you said it's a bit beyond me for now. At this point, I'd just be using the honor system. If you don't finish the level in 60 seconds, just kill your character off. This is funny. Okay, I'll take a Dorito. 9. Okay, we'll give it a try. We'll try to make this thing work, and I think I'll call it a day. Maybe I can do another one on Thursday. All right, so now, so we have a GSR going to pause. We just need, so just for the fun of it, I'm gonna call it here, just because, you know, I'm a crazy person, and, you know, get down to, you know, having so many GSR and routine within subroutine within subroutine. Although you have to admit that we have like 64K of stack. And you know what? That oh, I understand something. I just understood something. Oh yeah, yeah. We shouldn't play too much in the top end of the first bank because the vectors, the reset vectors are there, and also the stack pointer is there, which is possibly why we had problems before. Anyway, good reminder. Let's not go above like E0 or something so we don't get in trouble with the stack. Actually, I think I should move all my stuff above the first 64K, but that's for another time. Okay, let's resume. So we transfer our shit. We set the first Jumpman to be a 0524, which should be the same in the list at the bottom. Although I'm not even sure it should be there at this point, but I'm not gonna bother myself. So actually the first position is it should be a 050 actually. Actually, it should not be even on. So what I'm going to do is that I'm going to set its position I'm not going to do this. I'm just going to erase this here. Well, not erase, just put in comment. We're going to keep that. I mean, it's not really necessary at this point. I'm going to put it here. So we have set the position. No. No, this is not a good idea. This is a better idea. I'll put it here. I know it's stupid, but yeah. You know what? No, it's stupid. It's definitely stupid. Okay, let's put it back here. It's nonsensical. Don't worry. I'm crazy like this. Okay, let's set it to the first position, which is really 0. I should have like a blank sprite, nothing in it, and just set it up to the first blank. But anyway, so this is literally putting in the first position, which is like the first frame. Like I said, I should have a blank. I don't have a blank. I should get a blank. Okay, so I'm enabling the sprites, although I should enable the sprites at the end, not at the beginning. This would make more sense. Okay, all right, so that's more like it. Okay, so everything is set. So setting the value of the first pointer, which is the little bar, is feet. We see his feet. We set the position in the right place. It's at the top of the little pedestal there. We're going to enable hit, and then we're going to go into initializing to X. We're going to set the first address. We're going to push it. We're going to push the index. We're just going to go here. We're not touching X here, so we should be fine. Actually, I don't even have to push X, so I'm not going to play with the stack if I don't have to, which is great. So I increment X, and then I compare it to 36, not 36 I'm doing, and then I pause. So it seems pretty straightforward. So what could possibly go wrong? I'll tell you what could possibly go wrong. The timer will go wrong. I didn't play much with the timer. Daniel would be the best to guide us with the timer, but he's not here. And at the end of the day, we should see that thing appearing, and it should be like either, I don't know if a quarter second is enough, but we'll see if it gets close to the original. All right, we can tune it anyway. All right, so, because I'm not error with my timer association. I think I'm missing some include. So I'm gonna include defines. I think I'm missing interrupts. Are the interrupts there? No, interrupts is there. Timer is not there. def.asm. We'll put it at the top of the list. Timer block. There you go. Let's try to compile this again. Let's do it again. What's going on? What did I do wrong? Where is it? Source defines timer underscore def. Oops, I forgot the S. That's what I thought. Okay, let's do this again. Okay. Is everybody... Yeah, thanks, Kyle. You're very attentive out here. Well, I have a big screen in front of me right now. If you want to see, look, oh, it's a... This is my Wacom tablet. So it's a very big screen plus my 4K screen in front of me, which is very huge. That's why I always look like I'm looking at... Is it crooked or something? I always look like I look at above. It's not that I look above, it's because I look at the top of the screen. Anyway, so we're all set. I hope everybody's happy. Let's see if we're going to make this thing work. Okay. Anybody saw something? I didn't see anything. If I didn't know better, hold on, I'm going to... Yeah, it's missing. It's missing is part of his head. Okay, so maybe I'm missing a... Okay. All right, so there's definitely something happening, apparently, because our sprite is showing off. Too fast, yeah, no, I... No, I get it, Kyle. I know it's too fast. It's like, but okay. Before we go to tackle the before we tackle the speed problem, we're gonna tackle the last piece that we're missing. Okay, so if I go back to here, so that would be sprite 0, sprite 1, sprite 2, sprite 3, sprite 4, 5, 6, 7, 8, 9. Okay, so there's 9 sprites. Okay, so this is sprite 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 sprites. So that would be 0, 4, 8, 12, 16, 20, 24, 28, 32, 36. So why am I missing? No, I think the 36 needs to be included. So I think I need to put it to 40 because I'm incrementing just before. All right, so we're just to make sure that I'm right about this, we're going to do this again. Okay, so for the people on the chat right now, who has a unit? Show of hand. Who has a unit? Who's waiting for a unit? And who would like a unit? Meanwhile, I'm going to run this and see if we can see this little puppy appear. Okay, so there's a delay, and then the whole head is there now, which is great. There's only, okay, so it's like, okay, I think I know. I think it's because I'm running the timer once, it actually works. And then I'm running it twice, and then it doesn't work. So Dane, when did you order yours? I'm sorry, my memory again. Okay, so you're all waiting. Okay, so Norman, you know that the latest version of the IDE now does Wiki2. So if you want to do some Wiki2 stuff, I said it. I'll repeat it for the new people. I will be posting that code. I'll put the link to the GitHub in the description when we're done later today or tomorrow. From that moment, you can take that code and use it in the Wiki, in the IDE 0.501. The second you took down the waiting list. Okay, yeah. That's the last one, right? So you're in the second batch of the yellow boards, right? Anybody else? We're 7 on the chat right now, only 3 answered. Anyway, I'm not gonna force people. Okay, so good news. So we have something appearing. The first, yeah, it was 8. But maybe at that point, I think there was already 3. That's all. Anyway, it's coming. Trust me, when the Wiki is finished, all the bees are going out really quickly. And from that moment, then everything else, when I put some on sale, then they'll be really quick. It's just going to be the waiting time for the printing of the enclosure. All right. So we'll make this thing work, and then I think I'm gonna call it a day. So I think the first time it works, we do have a wait time because we see the first one happening, and then it waits, and then it never comes back again. I mean, it goes through like really quickly for the others. Sounds right? Hold on. Let me see. Let me see. Okay. Let's go back to the timer. Maybe I'd need to do a clear. But if it's going down, I really don't need to get it to clear. When counting down. Okay, but it's always 0. Counting down. 1 for it to cycle when counting up. Set to 1 for it to reload when counting down. Automatic reload. I don't need this. Hold on. It should work. So I'm putting in the value of charge. Normally charge goes back to 0. And then the only thing I do is run from the time. Should I clear it? Should clear it before? No, I'm going to recharge it with a value. So hold on. Maybe if I did okay, you know what? Well, just for fun, what we'll do is that we're going to, so what I'm going to do is literally count up instead of down just for fun. So we're gonna load the compare, and the compare stays the same every time. I just need to get the counter to go up. So that means that this guy here should be here. In reality, I don't even have to do that. I just have to do a clear. Actually, it's probably the most. So what I think I need to do here, you see, I designed the damn thing. I just don't remember it. So what I'm going to do here is clear the counter. So that should reset the counter back to 0. I'm going to set the comparator, and what I'm going to do after that is enable the counter. I'm not going to reload it because it doesn't need to be reloaded. The only thing I'll do is to up down, which when it's 1, it's going to count up. So, which means that it's going to count up. Here, I'm checking the pending registers. I'm ending it, so it's going to get 1. I wonder if I have to do anything else. The masking is I shouldn't have to mask it, not to play with the mask. This is polling, literally. I compare it with some old value. I'm looking to get a 1, I think. And if it's not done, I keep polling till it's right. And when it's right, it should, I clear the polling by putting it back. No, actually, you know what? I think I know why. Because I need to rewrite itself. I need to put a 1, not a 0. That's my problem. That's why I didn't. All right. I need to clear the to clear the pending register, you need to rewrite 1 in it, not 0. All right. That ought to do it. In both cases, it should work. Actually, this version with a comparator is a lot easier to do because, you know, it's shorter. All right, let's do this. And I feel that it's going to work. I have a good feeling. Okay, so compile. We're going to reset it. Everybody's ready? Excited? I think this is going to be a great downloading. Oh yeah, it's actually working, dude. Yay! I don't know, 250 milliseconds seems like a long way. Something is wrong here in terms of time. Okay, let me think. Ta-da, yeah, but it's like, it's very slow. Okay, let's cut it down by half. It's not very, it's a bit counter. Okay, let's clear this. Okay, so 14 megahertz, the inverse, that's the period. We already saved it. Duh. Okay, so I want to have 125, which seems to be better. Going back to the programmer. Oops. No. Oh, it's because there's a 0.5. I get it. Okay, programmer, we bring it here. We put that in 1B, 4560. Okay. We'll put it here just for reference. Either it's not going as fast as I thought. So 1B, it's literally off. I think we're gonna have a great number at that point. 1B, 4F, 4C. Okay, so let's compile this. Let's reset it. Sorry, I was in my head for 2 seconds. Oh, I think I know why. I know why it's so slow, and I know it just goes around. It doesn't stop. Because I probably forgot. I think if I need to load. You see in the description, set to 1 for it to reload when counting down. But I'm not counting down, I'm counting up. So what it does is that, yeah, no, the deal is that it's actually going around the whole 24 bits. Thanks. By the way, guys, anybody who's waiting for a unit right now, a C4B unit, okay, something I could do to expedite your order is that if you would get yourself a USB blaster, the one I gave the link, I mean, it's $70 at DigiKey. And if you add this, then you could upgrade the latest version of Viki yourself when it's actually out. Then I could actually ship the unit, because the only reason I'm waiting is literally because of that. So anybody who wants to have their unit and they're willing to spend the $70 to get the USB blaster to reflash the Viki 2, because what I will do is send you I will fix my VDMA problem and I could send it out even if it's not completely finished right away. The cost is, yeah, you would need to get this USB blaster. So if you're willing to have it sooner, then that's the greatest way to do it. So the best way to go about this is that if you decide to invest in this, and the part number is on the store in the C256, $70 Canadian, like Canadian pesos, or like 70 smidgens, you know. So just drop me an email, steph@c256phoenix.com. Just let me know, hey, I'm waiting for this. I'm gonna get myself a USB blaster. Do you want to ship my stuff? And I'll ship it quicker. I'm not saying I'm gonna ship it tomorrow. I'm just saying that I can ship some of those units. Most people I sent email out before. I asked them, listen, if you want to buy this USB blaster, you can. I can set it earlier. Now there's no reason for me to wait. Aside of most of them just decided to wait. So if any of you are waiting, you wanted to get quicker, I could actually get you the link now if you want. Let me see. USB blaster. There's one at $426. That's probably not the one you want. Yeah, so it's $71, 71 Canadian pesos. It's really. This is the DigiKey part number. You'll find the right thing. They're the same thing in the US DigiKey. Okay, so let's get back to our timer. Okay, so the reason it's so fast, it's so slow, is because it's actually going around the 32-bit or the 24-bit count at full speed, so it never really reached a point, which begs the question. Okay, let me see. I'm trying to figure out a piece of code that is actually using the timer, that I could use it as an example. Slowed up, down. I'm thinking. Okay. Okay, let's see. Uh, set to 1 for it to cycle. I think that has to do with this here. Let's see if it makes a difference. If I looked at the FPGA code, I would probably see it. Yeah. Is that the real count? 50,000 times? That doesn't help us into finding out the problem here, but if anybody wants to calculate it, I mean, we can do a stupid loop with the nopes, that's for sure. Do you want to do it? Okay, so no, I'm going to put reload just for fun. I have to understand my own design. That's the thing. If I had the FPGA code in front of me, I would figure it out right now. Yeah, but that's not the nope is not the first one cycle. It's you do realize that we have to do like a million cycle. It's the read and write and everything. It's 125 milliseconds is a lot. There's a lot of looping. We would have to loop within loop within loop within loop. Now I'll try to stick with the timer. I just need to do it right. And worst case, I'll go and check in the. Oops, that's not exactly what I wanted. Yeah, let's try it this way. Okay, let's try it this way and see what happens. Not sure if that's going to work, but no, of course 64 days, but there was a timer in the 64 as well. Oh, something else we could do is we could count. We could count the starter frame, although a starter frame is Let me think. Okay, let's try it. Let's just see if it makes a difference. Nope. Although I swear to God that Okay, what would be the best way to go about this? The fastest way to go about this without bypassing the whole thing? We would have to okay, let me think how I would go about this. Okay, the best way to go about this is to have an example. Okay, you know what? We'll go on. Let's do that. We'll go on GitHub. We'll go on. Daniel has. I don't know. Let's see if there's any timer here. No timer here. He's not using the timer. I know that in the tracker, he does use he does use the timer. BMP to timer count, so he does use the timer. Is there a timer def tracker? Can you believe this? I designed the damn thing. It's almost impossible. Okay, so you see, so he's loading the charge with 0. He's loading the compare. He's setting the reclear. And then he's doing a timer as clear. Okay, let's try this. What do you think, guys? You know, this is how I go about doing things. So he's doing a reclear. You know, a little bit of cheating, I guess. However, it's hit. Oh, yeah. Okay. This is like going to be like this recursive type of thing. That's why I need to stop it after I'm done. I mean, okay, let's see if we've done right. So the charge is 0. Although something that could happen is that the timer could still be, no, probably not. Okay, we'll do the same thing. Okay, timer 0. Medium high. Okay, so that's what he does. He does. Okay, so he set the charge to 0. He loads is constant for different timing into compare. He does the recycling of the clear, count up for charge value to time compare. He starts that in the compare 0, and then he's doing the down blah 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 blah, and then later let's say if it does the mask, not the mask, pending. Okay, that's the timer reset keyboard. Let's say if he checks the okay, he clears the pending, so I was right. Well, not the first time, but the second time. So in order to clear the pending, you need to rewrite the value back to it. Otherwise, there's another instance here. Yeah, enabling the mask, putting 0 in the mask would make it enabled, so that means that it would trigger the interrupt. We don't want that. Okay, let's try this way and see what happens. All right, Dan, have fun. I'm almost done anyway. I'm gonna call it a day real soon. Thanks for coming. We'll be soon. Yeah, I might do this in a couple of days as well. I'll, keep going with this. I still didn't get my Jumpman to walk around, so we'll get that next time. But I think it's a great thing that we can sort out the timer before we go, so we can actually use it more and more later. I'm sure it's going to be coming handy at some point. All right, so we're going to send the binary. Oh, it works! Da-da-da! So cool, huh? Still quite slow. What do you think? I'll do it again. I can do the music. Actually, it's pretty good. What do you think, guys? I think we reach our I think we reach our destination tonight. Any comments? Questions? No? Yes? Yes, question? Question? Looks good. Yeah, it's the timing is kind of right. Don't you think? Again, I think at some point that should be part of the interrupt state machine, stuff, but it's a good start. It's amazing how much you need to do the Jumpman pose. What's the Jumpman pose? Yeah, Dane, before you go to sleep, you actually saw it, right? Let's see it again. We can all do the music in our head. And this is another thing we'll have to do at some point, the music. I have no idea how to go about this. I mean, in theory, there's a SID in the Foenix, but it's not even very close to what it should be. We could use the 76. We could use the noise thing in the other sound chips anyway. Or maybe we could do like sampling, although that would kind of be cheating. Okay, so let's do that again. Do it. There you go. 125 millisecond. This is freaking awesome. I'm proud. Dude, this is so cool. All right, guys. So if you have any questions, I'll give you another few seconds if you want to ask anything about anything. Like I said, I think I'm going to do another one on Thursday. I'll probably post it and schedule it as well. And again, I might do, like I said, at least 2 per week or 3, maybe a third one on the weekend or something, maybe Sunday. Make it like a usual, like a regular thing. So if there's no other questions, thanks for being here. It's really cool. I mean, we're not a lot, but we'll probably get better and more over time. I just need to get more units out there. And soon you'll be able to play with yours. I will be posting the code either tonight or tomorrow. I'll post it on the description of the stream. And if there's anything else, if there's not anything else at this point, then I'll let you go and you can have a wonderful night. And I will see you very soon. All right, guys. Ciao. Thanks, Kyle.